This video, I'm going to prove a nice fact. If n is greater than 2, then there exists a prime p that's always in between n and n prime. Why n is bigger than 2? Well, the thing is that 2, if n is 2, that actually equals 2 factorial. So good luck getting a number in between 2 and 2. That's not going to happen. Now, if n is 3 or more, 3 is less than 3 factorial, which is 6. And the right side grows much faster than the left side. Now, 3 is not that far away from 6, but 4 is a lot more away from 24 than 3 was away from 6. And 5 is nowhere near 120. It's 115 away, etc. 6, when you compare it to 720, it's over 700 away. And the deviation between n and n factorial is always, if n is at least 3, n factorial minus n is bigger than or equal to 3. That is, we can find a prime in between, in theory at least. For example, between 3 and 6, we can find a prime. Between 4 and 24, we can probably find many primes. Between 5 and 120, we can find many primes, like, say, 119 or 7. So, on that note, let's get into this. So, there's motivation why they say n is 3 or more. Before we do the proof, I want to remind you, if you like seeing mathematical proofs, then you should definitely subscribe to my channel, as this is all we do on this channel. We do proof after proof after proof. Okay, so let's see. I guess there are two cases. Case 1. N factorial minus 1 is prime. Call it P. That is, call this P. Now we have that n is less than P, which is n factorial minus 1, which is less than n factorial. Remember, there's a gap of at least 3 in here. So 1 less than this number won't be n, and it certainly won't be less than n. It will be strictly in between n and n factorial. Case 2. Suppose n prime minus 1 is not prime, is composite. Then there exists a prime factor P for n factorial minus 1. But that implies that P divides n factorial minus 1. Now, we want to show that P is in between n and n factorial. So suppose otherwise. Suppose p is less than n. Now that's where everything comes together. That means p divides n factorial, because n factorial is a multiple of n. It's a multiple of n. Alright, so now we have over here p divides a number, and p divides one less than that number. That can't be. This implies that p divides the number, divides this number, minus that number. But this minus that is 1. But if p divides 1, that implies p is 1. But that's a contradiction, because a prime is always 2 or more. Okay, so what are we contradicting? What we supposed. So this implies that n is bigger than p. Sorry. This implies that n is less than p. And p is less than n factorial. Now where can we get that? Well, p is a factor for n factorial minus 1, and n factorial minus 1 is not prime. That means the factor must be less than that, which in turn is less than n factorial. So whether p is less than n or n is less than p, p is certainly less than n factorial. I mean, it could have been that p is less than n, which is less than n factorial. P is less than n factorial. But p is also bigger than n. And that's what we wanted to show, and we showed that in both cases. We showed it in case 1, that the prime p is in between, there is a prime p between n and n factorial. And in case 2, we showed that there's a p in between n and n factorial. Combining both cases, we get that n is less than p, which is less than n factorial. And that's what we set out to show. We did show that, and that completes the proof. If you like seeing mathematical proofs, subscribe to this channel. That's all we do here, are mathematical proofs. If you're into that, it's a no-brainer. Hit the subscribe button. See you guys in the next video. Remember, watch and learn.